Hello everyone, welcome to my channel. Today I'm gonna discuss some important problems on epoxide ring opening reaction which came in CSIR Net and Gate. So let's start. Yeah, this is the first problem. We have to predict the major product. I'm not giving the options. You can check the paper of June 2011. Yeah, all right. You have a transdecorating system. Yeah, you can see here methyl and hydrogen are at transposition and epoxide is at the above, and we have given one nucleophile that is pH is Na. So it will come from the less inner position, that is axial position, right? So what will be the product? Methyl will be at the above, hydrogen is below, and this at the axial position is pH, and at the above position we have OH after hydrolysis. So the product will be like this. Right, this is the product. So next, coming to the another question that is came into GATE 2019. This is quite simple, but concept you have to utilize it. Conceptually you have to utilize it. So we have cyclohexene, and there is peroxide is there in presence of benzene 0 degree Celsius. We have to predict the product P and Q. The difference is here R is OE, R equals to H, and here R is another group, COET. So to predict this product, we have to make it into the cyclohexene half chair form. Okay, this is cyclohexene, and we have COET. Okay, we have to predict where the epoxide will form. In this case, it will from the below side. If it is in our position, that is it will be anti-epoxide. But when R equals to H, it will be seen how it looks like. So you can see here the coordinating oxygen makes a hydrogen bond with that hydrogen of OH group. So it comes from the same phase where OH is placed, that is cis phase. So it will be the syn type product, that is this is above, and in this case it will be anti-epoxide. Yeah, you can make it below and make it above, no problem, but it will be anti. Okay. Next, coming to another question which came into December 2019, we have to predict the product. Again, I said I am not giving the option. You can check. Yeah, first will oxygen will coordinate boron. Okay. And there is hydrogen. Then hydrogen will migrate here and it will flip back. What will happen? So this is carbocation and will be stabilized by the oxygen lone pair. And after that it will be like keto. So this is the product. Okay. Next, coming to another question from December 2019. First, we have to see, we have to make the epoxide. Where the epoxide will form, it will be above or below. See, there is one above groove. So basically, to avoid the steric, the epoxide will form from the below position. You can predict this easily. Okay. I am not giving the exact mechanism. So 8A will be like this. Simply because the methyl group is the above position, so epoxide will form from the below. Okay. After treating with hydrogen and ACOH in presence of ACOH, what will happen? We have to predict this. First, nitrogen will react here and it will form imine. I think all of you know this. Then nitrogen lone pair will come and this will come here and epoxide will break. Okay, this will form. And after liberation of nitrogen, it will take a proton. Yeah, there is another methyl group. Okay, so this will be the product. This is from GATE 2005. It is also quite simple. In place of PPH3, I minus will liberate. So basically this combination will liberate I minus, that is nucleophile, which will attack at the epoxide. This is above epoxide, so I minus will attack from the below position, which will be the suitable this center. Okay, or you can simply predict from the cyclohexane chair form like this. Here tarbutyl group is there at the axial position, at the equatorial position, and we have to make the epoxide at the above like this. Okay, here two positions are available, and one is equatorial and another is axial, so I minus will come from the axial position. So in both cases the product will be the same, that is okay, this will be the product. Another question from GATE 2004. There is cyclohexene given and we have to predict the condition, which condition suits the product between 1 and 2. So there is three condition given, phi, q and r. We have to predict the appropriate option from this. So you can see there is cyclohexane there, and one epoxide is above and one is below. If you look at the product P, you can see there is epoxidation in presence of acidic medium, and this will go work for 1, simply because why? I am giving you the mechanism. Here you can see this group is there, and in this case this group is there. So to avoid the steric, it will come from the exo side, that is this side, so it will be from above side. Why this is coming from, approaching from the exo position? Because to avoid the steric with this group, because it comes from the endo position, then it will interact with this group. So this is not feasible, this is feasible, and this will go and this will give this product. So for one, in this case this will be the P, and for two product, what will be the correct condition, or what will be the exact condition? It will be basically R. If you see the mechanism, it will be better understood by you. First, bridge will form with the bromine, and it will form the exoside to avoid the steric. Okay, this is from above side, and anyways there, so basically OH minus will come from the below side. and in presence of NaOH it will also be deprotonated and this will attack here and bromine will leave. So basically epoxide will form, and this from below epoxide. Okay, so this condition is suitable for product 2, that is R. Another question from June 2016, we have an epoxide and Wittig reagent is there. So what will be the A? Like this, anti-epoxide breaking down, you can say. So basically this will be A, and after treating with this, as this is unstabilized elite, so cis product will form. Not actually cis, Z product will form. Okay, okay, this will be the product. This is Z double bond. This question came into June 2016. Pretty simple question. Here LA is given and it will attack from the which position? This one or this one? Here you can see this is equatorial hydrogen and this is the position where hydrogen is at the axial. So hydrogen from attack from the axial side, this side, and this will broken. Okay, and here it will be hydrogen will be at the above position and which will be at the below position. So the answer will be like this. Here is oxygen, here is oxygen. Yeah, like OH. Okay. Coming to the next question, and this is the last question, and this is also from June 2013. If you look closely at the options and the products, you can easily eliminate the two options because here is given alpha beta unsaturated double bond, and we know MCPB does not react at the alpha beta unsaturated double bond. It will react at the isolated double bond, that is this. But in product we have to make epoxide at the alpha beta position. So basically we can easily eliminate the MCPB option, that is A and B. We can eliminate this. So the suitable product is H2A2 in presence of NaOH, but which will be the major one? For this we have to go through the mechanism. Okay, so basically first epoxide will form from the above position, but how? In presence of H2O2 and NaOH, it will take proton from H2O2 and will make OOH minus, and this will come here. and this will go down and this. This is above because this group is below. So to avoid the interaction, it will be at the above position and this comes back and attack here, and which will be liberated. So the product will be like this. So this is the product. So the correct option will be D. Okay, this is the mechanism you can see. Yeah, so thank you for watching this video.